This is a continuation of lesson 1.3 in geometry. So the Pythagorean theorem is used to find the missing sides of a right triangle. So in our picture, the sides that are labeled as A and B are called legs, while the side that's labeled C is called the hypotenuse. And the hypotenuse always is the longest side of the triangle, and if we look at the location of the right angle, we can point to the hypotenuse because the hypotenuse will always be opposite of the right angle. And for every right triangle, we can make an equation where a squared plus b squared equals c squared. So the squared of the two legs equals the squared of the hypotenuse. So for our examples, we're first going to identify which side is C. A and B are interchangeable, so I could label A and B or B and A. But this side, opposite the right angle, right, pointing at the side, is C. So when I set up a squared plus b squared equals c squared, x and 3 will go in for a and b, and that will equal c squared, which is 5 squared. So to solve this, I'm going to keep x squared alone for now. I'm going to do these squared, so that's going to be 9 and 25. I want to get what's being squared alone, so I'm going to minus 9 from both sides. So now we have x squared equals 16. And the opposite of squaring something is taking its square root. So I'm going to take the square root of both sides, and if I do that, I get 4. All right, that's a nice number because 16 is what we call a perfect square. So we didn't even have to round that one to the 10th. All right, looking at the next one, if I look where my right angle is, opposite it, that's our C. So we're going to use 4 and 6 as A and B, and that's equal to x squared. So 4 squared is 16, plus 6 squared is 36. Add these together because x squared is already alone, so I'm going to simplify this side. That becomes 52. And now I'm going to take the square root of both sides because x squared is alone, the other side is simplified, and this we do get a decimal. So we're going to round this to the nearest tenth. That's one place after the decimal. So we can call this 7.2. All right, you're going to try the next examples. You can pause, and then when you're ready, play to check your answers. So let's check our answers here. For the first check in, x is 12.1. It was one of the legs that we were finding. And in number 2, x was the hypotenuse, and we get 15.3. So we can also use the Pythagorean theorem if we don't have a picture of a triangle drawn yet, but we can draw one. So in this, it says use the Pythagorean theorem to find the distance between A and B. So I am going to finish this picture and make a right triangle using those two segments. So now I'm looking for the hypotenuse. I know this side can be counted as 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6, 7, 8. So using the Pythagorean theorem, we would have 6 squared plus 8 squared equals c squared. So that's 36 plus 64 equals c squared. Combine like terms, 100 equals c squared. And then take the square root. So we get 10 equals c, which means the distance between A and B is 10. So you're going to do the next check-in, same idea, create yourself a right triangle, find the distance between the 2 points. Pause so you can check your answer. All right, so we didn't have names for these points, so we don't have to call it any segment name, but that missing side, the distance between those points was 5. So we actually have a formula that we can use so we don't have to draw the triangle. All right, especially if we don't have the coordinate plane for us, the formula is going to be much easier to use, and it's called the distance formula. So the distance formula is based on the Pythagorean theorem, and what happens is we're going to take x sub 1 and y sub 1, the first point, and x sub 2 and y sub 2, the second point, and we're going to plug them into this formula. The square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. All right, so this is what we call the distance formula. So we are going to use the distance formula on both of these, even though we could draw the triangle and we could check it afterwards to make sure we're right, but we're going to use the ordered pairs. So this first ordered pair goes back 5 up 3, so that's -5, 3. And this one here went back 2 down 3, so -2, -3. So using these 2 points, and I'm going to rewrite them here, we're going to call one of them x sub 1, y sub 1, and the other one x sub 2, y sub 2. And now we're going to plug them into the formula. It's x sub 2 minus x sub 1 squared plus y sub 2, that's just a 2, minus y sub 1 squared, and the whole thing goes under the radical. We don't want to get lazy and lose any of these parts, especially the radical sign, the square root sign. So minus a negative is like changing into a plus, right? That's a plus sign. So we really have -2 plus 5, which is 3. And then -3 minus 3 is really a -6. So we have to be careful here. If we're using a calculator, when we go to put this in, we need to keep the parentheses around it, because this is different than this. This is saying do 6 squared and then make it negative. This is saying square everything that's -6. So if we do this, we should have 9 plus squaring a negative gives us positive 36. So now it's the square root of 45. All right, the directions right here, but we're going to round to the 10th, just like we did before. So the square root of 45 turns out to be 6.7. Right, and that would be the distance. We could have checked that, right? If I counted the boxes this way, there were 6 boxes going this way, and counted the boxes here, there were 3. So 6 squared plus 3 squared ends up as square root of 45, ends up as 45, and when we take the square root, we get the square root of 45. All right, let's try the second one. This just gives us the points. So let's label x sub 1, y sub 1, x sub 2, y sub 2. So that's going to be 3 minus -4, which again, minus minus, we could turn into plus. And then -1 minus 1. All under the square root. So 3 plus 4 is 7 squared, plus -1 minus 1 is -2 squared. So that's going to be 49 plus negative times negative is positive 4. All right, and here's a tip. We will never, ever, 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 ever have a negative under here. So if something happened and you squared your number and you ended up with minus something, go back and look at that, because it should always be plus. So that's the square root of 53. And if I take the square root of 53, I get 7.3. So that would be the distance between A and B. We could actually write it as AB equals 7.3. All right, we are missing the problems. Let's add them in for you. So I'm just going to put one here for you. Find the distance. Right, this is our check-in. We're going to do distance between E, which is -7, -2, and F, 11, 3. So go ahead and try that problem. Pause it, so when you're done, you can check your answer. All right, let's check our answer here. So we use 11 minus -7, which turns into 11 plus 7. We have 3 minus -2, which turns into 3 plus 2. So now I have 18 squared plus 5 squared. I end up with a square root of 349, and that means EF equals 18.7. For our last problems, we have some word problems. So your school is 4 miles east and 1 mile south of your apartment. So assuming our apartment is at the origin, A for apartment, the school is 4 miles east, so that's 4 to the right, and 1 mile south, so 1 down. So our school is at 4, -1. And then it tells us a recycling center, where your class is going on a field trip, is 2 miles east and 3 miles north of your apartment. So 2 east and 3 north would be the recycling center. So that would be 2, 3. We want to estimate the distance between the recycling center and the school. So we're going to find the distance between these 2 points. 2 minus 4 squared plus 3 minus -1, so I'm going to change that, minus -1 squared. So that's going to be -2 squared plus 4 squared, or 4 plus 16, which is the square root of 20. And if I take the square root of 20, I get 4.5. And because everything was in terms of miles, it's 4.5 miles. So you're going to try the next one, which uses some of the same information. So let's look at it for a second. Using the previous example, a park is 3 miles east and 4 miles south. So 3 east and 4 south would be +3, -4. And if you recall, the point from our school was 4, -1. So find the distance between the park and your school. Pause, so when you're done, you can reopen and check your answer. All right, so using our distance formula, we end up with the square root of 10, which comes out to be approximately 3.2 miles. And that is part 2 of section 1.3.